we're covering differential equations for the FE exam, a topic found in the mathematics section of the NCEES FE Reference Handbook. On the exam, you won't be asked to derive complex proofs. You'll be expected to recognize a specific type of ordinary differential equation and apply the correct solution method directly from the handbook. Let's start with first-order linear differential equations. These appear in the standard form y prime plus p of x times y equals q of x. The key to solving these is the integrating factor mu, which is given by the formula e to the integral of p of x dx. Once you calculate this factor, you multiply the entire standard form equation by it. The left side magically simplifies to the derivative of mu times y. Then you integrate both sides and solve for y. For example, if you have y prime plus 2y equals 4, your p of x is 2. The integrating factor is e to the integral of 2 dx, which is e to the 2x. Multiplying through gives you e to the 2x times y prime plus 2e to the 2x times y equals 4e to the 2x. The left side is the derivative of y times e to the 2x. Integrating both sides and solving for y gives you the final answer. A common trap is a sign error when identifying p of x if the equation isn't in perfect standard form, so always rearrange it first. Now, for second-order homogeneous equations, which have the form ay double prime plus by prime plus cy equals 0. Your first step is to write the characteristic equation, which is ar squared plus br plus c equals 0. You then solve for the roots r using the quadratic formula. There are 3 possible cases for these roots, and the FE Handbook lays out the solution form for each. Case 1 is 2 distinct real roots, r1 and r2. The general solution is y equals c1 e to the r1x plus c2 e to the r2x. Case 2 is a single repeated real root, r. The solution is y equals c1 e to the rx plus c2 times x times e to the rx. The number 1 exam trap is here, forgetting that extra x in the second term. It is absolutely critical. Case 3 is complex conjugate roots in the form alpha plus or minus beta I. The solution is y equals e to the alpha x times the quantity c1 cosine of beta x plus c2 sine of beta x. A great mnemonic for the repeated root case is, if the root repeats, the x competes, to remind you to add that essential x multiplier. Finally, let's touch on Laplace transforms. The FE exam won't require you to compute a Laplace transform from its integral definition. Instead, you'll use it to solve more complex differential equations, particularly those involving mechanical vibrations or electrical circuits with discontinuous forcing functions, like a step input. Your strategy is to use the table of Laplace transforms in the handbook to convert the entire differential equation from the time domain to the S domain. This turns it into an algebraic problem. You solve for the transformed variable y of s, and then use the table in reverse, often with partial fraction expansion, to find the solution y of t. Know how to find the transform of first and second derivatives in the table, as this is a very common exam application. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.